Hello student, my name is Imran Ahmad and today lecture we discuss about the PN junction diode. PN junction diode is nothing but it's a combination of p-type material and n-type material. If we are separately we are talking about the p-type material and n-type material, then this type of material is the very few use. But when we join a piece of p-type material and piece of n-type material, then a PN junction diode will be formed, and the PN junction diode will be many used in many electronic circuit, like as rectifier, amplifier, switching, or we can say that in a half adder, full adder, and logic gates, etc. Here is the electronic symbol of a PN junction diode. Here we can clearly see that this is the electronic symbol of a PN junction diode. The triangle represent the flow of current, and line represent that in only one direction current will be flow. In other direction there is no current flow. So this, if this is the positive and this is a negative, so this is the forward bias we are talking in later. If this is the positive, this is a negative, so in only in this direction current will be flow, but in this direction there is no current. So this is the line represent. This is the another block diagram of the PN junction. This is the p type material and this is the n type material. When we combine the p type material with the n type material, then there is the depletion region will be created. So what is the depletion region? Depletion region is nothing but it's a potential barrier. How it will be created we will see in the next slide. So here we can see that here is the depletion layer. How it will be created when n-type material and p-type material will be combined. So electron from n-type and hole from p-type will recombine to each other, and immobile ions will be generated at the junction, and this result that the depletion region will be created. Depletion region also known as a barrier voltage. We can say that this is the barrier voltage because one side is the plus charge and another side is a negative charge, so that a voltage will be generated, and this voltage is known as a barrier voltage. In next slide, diode biasing. Diode biasing may be forward bias or reverse bias. What is the meaning of forward bias? When we apply here in the p side positive and here is the negative, then this is the forward bias. In case of forward bias, positive charge, this positive charge will repel the whole of the p-type material, and this negative charge repel the negative, means electron, from the n-type material. So there is a repulsion, hard repulsion will be take place, so recombination at the junction will be very fast, so that depletion layer will be very thin in the case of forward biasing. In case of reverse biasing, what will be happen? So in reverse biasing there is the negative voltage, negative, and there is the positive. So due to the negative, all hole will be accumulated at the terminal, and all negative will be attracted or accumulated at the n terminal. So lot of more chances to accumulation of charge here, and that's why the depletion layer will be large as compared to the forward biasing. So this is the concept behind why in forward bias the depletion layer is thin as compared to the reverse biasing. So the another question, how to test PN junction diode? We know that in forward bias the resistance is very low, and in reverse bias the resistance is very high. That's why the diode is called as a unidirectional device, because in high resistance there is no current. In ideal case, if resistance is high, then there is no current, but when resistance is very low, then current is very high. In this case there is no current ideal, and in forward bias case there is a low resistance, so current is very high. That's why the when we may draw a characteristic of PN junction diode, this is the forward bias, this is the reverse bias. So only in forward bias the current is will flow. In reverse bias there is no flow, zero current. After knee voltage there is the load. This is the another concept. We see the only this part and this part. So I think the concept is clear about the PN junction diode. So next question arises, the how in a laboratory the PN junction diode look like. So here we can see that there is a lot of PN junction diode. This is the general diode, tunnel diode, or varactor diode, normal diode. There are the many type of diode. So all diode contains the P type and N type material, and some mixing, some impurity. We can discuss about the impurity diode in next lecture.